Okay. Awesome. Awesome. Hi gamers, I'm here. How's it going, everybody? I said fuck it, we ball. We're doing math now. We're just gonna do math. We're gonna do math. When was the last time I did math? I don't fucking know. I'm going a little bit insane. I have to write like 9 pages of an essay tonight. But like, who cares about that? Well, we could be doing fucking math. We could be doing math right now. We could literally be doing math right now, guys. Which is what we're gonna do. We're gonna do some fucking math. Here's some math. Don't hit 44. I did that one wrong. We're gonna do some. Oh my god, my desktop audio is so loud. Okay. I'm a little all over the place. It's raining. I have developed a mild eye twitch from trying to write this essay. I'm not very good at writing essays. That's why I'm an engineer. So we're just gonna fucking do some math because I give up on doing the other thing. We're just jumping right the fuck into it. Today's a me saying a lot of swear words day, I think. I think that's what kind of day it is today. High energy Damie. See, I'm in math, right? I'm in the right category? Maybe? Math. Hey baby, there's 3 people streaming in the math category. That's cause for celebration. Who the hell streams in math? No one, ever. Okay, let me close some stuff. Then we'll get right to it. I'm gonna close my essay. There we go. Get the fuck out of here. I'm streaming math. You're streaming math, Umbra? Umbra, let's co-stream math. Here, Umbra, you wanna do my final exam with me? I don't even have my tablet out. Where the hell is anything? Imagine if you were streaming math, Umbra. I'm streaming math, though. Okay, let's fucking ball out. Let's ball out, guys. Let's... Alright. Okay, number 1. We're gonna go into it. This is my final exam practice. If I fail this, then my professor blows me up with a nuclear bomb. Okay, we have to draw an ellipsoid. This kind of ellipsoid. X squared plus 2y squared plus 4z squared equals 4. Okay, this is gonna kind of look... Oh, it's not gonna look strange, because I know how to do this. I know how to do this, gamers. We do this. Divide everything by 4. Okay, we get x squared over 4 plus 1 over... Oh, sorry. Y squared over 2 plus z squared over 1. Don't ask why there's a 1 there. That's because I'm awesome. Okay. Okay. 1, 2, 3, 4. Easy. 1, 2. Easy. 1. I'll put 4 on all of them. I don't know why I didn't do that in the first place. I mostly just do that for scale. Okay, x, when everything else is 0, x is gonna equal 4. When everything else is 0, y is gonna equal 2, and there we go. It's gonna look something like this. Like something like this little funky thing. I did have to draw it. I was confirming that I had to draw it because I got a little scared for a second there that I just didn't have to draw this thing and I was just like falling out for no reason. Oh wait, this needs to be like way longer. Oh, we're doing a little maximization problem, chat, even. A little maximization. Oh, a little maximizing. Oh, also, Umbra, I don't know if you're listening, but I will say, I printed with the PLA that came with my printer, because I was like, bro, I don't want to wait like 4 days to get this PLA to get here, and it was fine. It was awesome. I mean, it wasn't awesome, but it's also all used up, so it was just a test print, it's fine. Hopefully it doesn't fuck up everything. Also, I did find another person who says PetG online, and I'm gonna call it that. Fuck you. That was mean. I'm way too high energy right now, I don't know why. Way too high energy for like barely keeping it together. Anyway, largest volume of the largest rectangular box. Whoever it is, I'm gonna beat them. No. No, actually, my shop techs said it, so that's why I started saying it, because they said it, and I was like, okay, you're a shop tech, so I'll just say it. Anyway, largest rectangular box which can be inscribed in this ellipsoid. Let's just like make it not look like a garbage real quick. Okay. So, this is great. This is so silly funny because we have to do much more work. And by much more work, I mean not that much work. Okay, we do need to define this height as a specific thing, and it's gonna be twice everything, basically. Okay, we're just gonna like, this is close enough, right? Basically, that's the thing. Okay, this point is gonna be X, Y, Z. Okay, so that means that if this is our box, bam, 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 that means that this is gonna be, so from here to the axis, that's X, so it's gonna be 2X. From here to this, that's gonna be 2Y. And then from here back, it's gonna be 2Z, baby. We got 2's everywhere. Twice the love, twice the box, baby. Actually, 8 times the box. So our volume is going to equal 2y times 2x times 2z equals 8xyz. Okay, now can I remember how to do this? Is a great question. We can do this. Okay, we can do it 2 ways. We can do it with Lagrange multipliers, which might be kind of the play. Because so this is gonna equal our f. My giant fat head is in the way. Sorry, my head's not fat. It's just my ears are big. They're big and comfy and fluffy. Okay. And then our g of x is gonna equal... Man, let me just write this as a system. I'm gonna write it as a... Can you turn my music down a bit? Sure. 1000%. Now it's chill. Now it's chill music. That was the me going insane music. Okay. So we've got... Oh, my back hurts so much. It's fine. 8xyz equals v. Yeah. Wait, I need to maximize this actually, so we'll just go ahead and do this. No, we can't do that. Do I remember how to do this? I think I do. I feel like I should do this with Lagrange. No. We're chilling. Let me do this first. Let's just write this. 8xyz equals v, and then x squared plus 2y squared plus 4z squared equals 4. Okay, if we want to do this with Lagrange, because, like, you know what, we'll see. I want to offer you... Cool, thanks first-time chatter who's definitely not a bot. I don't even know if I can delete that from my dashboard. I don't think I can. How do I... Okay. I'm a Twitch streamer. I'm a Twitch streamer. How do I... Whoa! Umber, you have a watch streak of 3. I don't know what that means. I didn't know that was possible. I didn't know that that was... Show mod icons. Oh, there we go. Delete. There we go. Haha. Win. My entire brain just turned off because of that. Okay. Back to this. Alright, we need the gradient vector for v. So the gradient vector is going to equal derivative with respect to x. That is going to be 8yz, 8xz, 8y xy. Said every letter there. And then g is going to equal, the gradient of g is going to equal 2x. Okay, this is 4 minus blah, 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 right? So 2x, 4y, 8z. Can I explain null space? Oh, do I remember null space? That is a great question of my book of linear algebra that is actually always under my desk because you know how you have like parachutes like under the seats in a plane? You don't have parachutes. Life preservers. That's just me with my linear algebra book. Null space, null space, null space. It has to do with zeros, right? It's got to do with the kernel. Is it the same thing? I don't remember. Let me see. Let me see here. Do I have in giant letters a thing that says null space? I hope I do. I probably don't. Let me see. I'm gonna look for this real quick, and if I can't find it, then, I don't know. Probably keep looking for it. Vector spaces. Matrix representation of linear transformations. Where's my null space at? It definitely was... We had the rank nullity theorem. I very clearly remember this. Wait. Kernel. I saw a kernel mentioned. Invertible transforms. Ah, here we go. The null equals the kernel. Which is... Is it equal to kernel? Okay. Basically, the idea of... Wait, let me make sure that that is what it is. I mean, it makes sense with the name. Wait, let me check. How am I doing? Oh, hello, person. I don't know who you are, but I'm doing all right. I'm balling out on math. Let me look up one thing to see if the nernal is the null space. Yes. Okay. Okay, the way that, I don't know, the way that we described it, I'll just do it real quick. Okay, you have one thing, and then you have some thing, right, where you're going to another, you're using a linear transformation to take these numbers in A and put them into B, right? So they turn into different values here. Basically, and this is like, there's a matrix that represents this. Basically, the kernel is a subset of ways that you can get here, right? So, like, subset of vectors that when you... On this side, all these vectors, all these ones, specifically point to the zero vector. So whatever, like, you know, the zero vector. I was looking, came across your screen, you're doing a great job. Thank you. I'm slaying a little bit, just a little bit. So yeah, all of the vectors that turn into the zero vector, when you apply this transformation to them, those vectors exist as the null space. And there's a way that you can mathematically find that. And if the kernel only has one vector, and that's the zero vector, because the zero vector is always going to be in it, right? If you transform the zero vector, it's going to be zero. Sort of like how if you multiply anything by zero, it's going to be zero. Because that's all a transformation is. If it only has the zero vector, then that means it's a one-to-one function. So that means that, like, for every vector that you put over here, they all go to, like, different spaces. So if we make this star a bit bigger, if we have a spot that's like, this is the zero spot, it means that, like, we could have a vector that starts here and goes there. We could have a vector that starts here and goes to zero. We could have a vector that starts here and goes to zero. These three vectors would make up, and, like, all the other vectors just, you know, went somewhere else, right? These three vectors would make up that kernel. But if we had something that was like, blah, 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 there's one vector that goes to this spot that's zero, and all the other vectors go in different directions, then that means that all these other vectors are unique in the places they go. So there's, like, one-to-one. Thought I solved that problem. Apparently I didn't. Where's my other... Where's my... This one's my tablet, I think. Is it? Yes. Okay. That'll solve it. That makes the rest of my life harder, but it's fine. Yeah, I just turned into a space demon, it's fine. Okay. Oh, I forgot my mouse doesn't work. Oh, you know, just the technological horrors. Just as you do, as you do. Well, this is what you come for on the stream. The cosmic horrors. There we go. Okay. Time for Lagrange multipliers. Why is this calibrated so strangely? Oh, I forgot my keyboard doesn't work either. Nothing functions. I'm normal. Okay. We're getting this done. This is gonna be done by the end of this. Alright, I gotta get rid of— oh my god, I forgot that. Oh no. I don't actually know if I can do this chat. Chat, this is gonna be so scuffed. Do I have any of these as pan? Shift, Control, Alt. Your VTuber isn't as good as much as it should be? That's funny. I made him myself. I actually really want to remake him, just because I am better at making VTubers now. Also, I have a pretty big, the only thing that's really scuffed— can I help you with it? The only thing that's mostly scuffed is that I don't open my mouth that much when I talk, so if I articulate my lips, it does get better. But, yeah. He has a pretty wide range of motion. He's also very, like, the fact that he even exists at all is kind of a technological miracle, because the way that I cut him, because I drew him and rigged him, is not normally the way that you do VTubers, so. But I digress. It's math time, baby. Okay, so we get 3 equations out of these 2 little guys, because we're doing— I can redesign my profile. Oh no, I can do art myself. You're chillin'. I actually have so many ideas. Don't even get me started. Don't even get me started. This is 2 lambda x. We get our little lambdas in here, because what we do with Lagrange is we just say, oh, that's not the right thing. We do that. We say that you can't see it. We say that f equals lambda times the gradient vector of g, and then we can get 3 equations out of that. So 8yz, and then we'll say 8xz equals 4 lambda y, and then 8xy equals 8 lambda z. Okay, so the 8s go away here. Now we can— oh, that was really loud. Sorry about that, gamers. Okay. We probably just want to grab 2 of these to divide by. I'm kind of thinking— actually, we don't even need to do that. We can say lambda equals xy over z, and then we can plug that into 8yz equals 2, so that'd be x squared y over z. Do I want to do that actually? That's kind of annoying. I'm wondering if this is faster with not Lagrange. Because if we did not Lagrange, it would be— no, it would be a square root. Well, actually, yeah, that might be kind of nasty too. Oh, we'll do it with Lagrange. Okay, but we can do— let's see, what can we do? 8yz divided by 8xz equals 2 lambda x over 4 lambda y. This and this go away. The z's go away. Okay, we're getting somewhere. This goes away. So x over y equals 1/2. Or sorry, y over x equals 1/2 x over y. And then we go for a little 2y squared equals x squared. Hey, that's not too bad. That's not too bad. So then we get, what do we wanna put this into? Oh, we can put it into this original one up here. So we'll do that. Now I also need one for z, so let's do 8xz over xy equals 4 lambda y over lambda z. So get rid of this and this and this and this. So 8z, that'll be 8z squared equals 4y squared. So z, we are gonna get rid of, yeah, we're gonna have everything in terms of y. So z squared equals 1/2 y squared. And we take this and we take this and we put them into this, and that'll give us 2y squared plus 2y squared plus 2y squared equals 4. Normal math moment. This is taking up so much of the page and I didn't put it over there and it's annoying me. Anyway, 2 plus 2 plus 2 is 6, so y squared equals 4 over 6 equals 2 over 3. Y equals plus or minus square root of 2/3. And 2y squared equals x squared, so if y is positive, okay, we have to like do this out. Well, they're always gonna be positive, so fuck it, we ball. They can't be negative. I'm just gonna circle the positive, right, because it's lengths of a box, and lengths can't be negative unless we invent antimatter. So 4/3 equals x squared, x equals square root of 4/3, and then z equals 1/2 y squared, so z squared equals 1/3, z equals square root of 1/3. Look at that! We did it! We did it, guys! We did it! We did it! That took a while, but that was because I was looking up kernel, so we're not going to be too worried about that. I have a decent chunk of problems, but see, the funny thing is that the alternative to me doing this is writing an essay. So we're just gonna we're gonna smash through these, is what I'm thinking. Okay, we'll do that. Okay, and then let me nab this. That? No, I shouldn't split that up. Sorry, I have to use my other keyboard. I'm pretty sure it's my USB hub, like, power overloading, but this is gonna... Like, that makes the terrible, demonic screaming, which I thought I had solved. I really thought I solved it. But I didn't solve it, is the funny thing, so... yeah, not really sure about that, because what I need to have is being able to use a keyboard and a mouse, and then also my tablet, and that's already more USB ports than my computer has, so I have to use a USB hub at some point. But... okay. Cool. So... was it asking for the volume? Then find the volume of the largest... Cool, so we multiply these. Whoa. We are going to plug in that volume equation, so we have 2, 2, 2, or, you know, 8. V equals 8 times, so that was what, 4 over 3 times 1 over 3 times 2 over 3, I think. So that would be, ugh, god, square roots. So 8 times root 8 over 3? No, root 8 over 27, right? Is that how square roots work? I think so. If we put the 8 in there, that wouldn't be... oh, maybe... wait. I can bring the 8 out anyway. Well, partially bring the 8 out, I should say. We can do 16 2 over 27. I don't know if that's right, but we're gonna say it is. All right. Problem 2, directional derivatives, baby. Okay, we want, the equation is 2e to the y cubed. We want to find the direction of the unit vector, so we want a u, so that the rate of change at 1, 1, ROC equals 0. Alrighty dighty. So we need that gradient vector, that good gradient vector. Okay, so if we do with respect to x, that'll be 2x e to the y cubed. And then if we do with respect to y, we're gonna get x squared e to the y cubed times 3y squared. And we want this gradient vector, because this is representing our rate of change, we want the magnitude of it to be 0. And the only way the magnitude can be 0 is if both of these things equal 0. So 2x equals 0, and then we should also have the same thing if we had 3y squared x squared e to the y cubed equals 0. No, wait, I lied. Am I lying? I am lying. We don't want to do that. That would give us a bunch of cool equations, but we can do a lot faster way because we already know this point that we want. So let's just plug it in, baby, at 1, 1. That's going to give us 2 times 1 times e to the 1. 1 times e to the 1 times 3 times 1. Which is going to equal 2e, 3e. So now we need to say 2e, 3e dot our u, which is not going to be normalized yet, but it will be after we do it. We'll just call it AB. Needs to equal 0. So these are orthogonal vectors. All right, so that means that 2EA plus 3EB equals 0. Wait, find the directions by unit vectors. A plus B equals 0? Is that right? Okay, A plus B equals 0. Because you can, oh no, you can't factor that. 2A plus 3B equals 0. 2A plus 3B equals 0. So if we want to do this in a vectory way, we can say this. We can say because we know a little linear algebra. 2a equals negative 3b, so b equals negative 2/3 a. And then we go whoop. And we're gonna have our regular a, and then negative 2/3 a. And we want to multiply that by the square root of a squared plus 4 over 9a squared, which is 13? 13 over 9 a squared equals... I don't like... I'll keep that. No, we'll do it. 3 over square root of 13a squared. I don't know if that's the answer he wants. He might have just wanted one vector, which you could say would be a fun one, a great one would be, let's see, a equals 3, b equals negative 2. Also an option. Although that is not normalized, so we'd have to normalize that, but one option, right, is that. One option. We do a little thumbs up. Okay. Also find the direction by a unit vector so that it has the maximum directional derivative. Cool. That is actually not too hard. The answer is 2e, 3e. That's it. So this is 0 ROC. And then max is when it equals the gradient vector. So 2e, 3e. And then min is negative 2e, negative 3e. Easy, chat. What is the maximum directional derivative? Oh. And then we just need to do, the answer to this is the square root of 4e squared plus 4 plus 13e squared. That's the magnitude of it. We are chillin'. Alright, let me take a little sippy of water. Dude, it is wild how productive I am at doing math. Like, when I don't want to do something else. Cool. Alright. Oh, I forgot this is going to be a 3-hour exam. That won't be too fun. I'm so sad that I can't take you with me, chat. I can't keep you guys in my pocket. You can't be doing omega lulls and pogchamps at me. You guys would have been omega lulling so hard if you had been to my last math exam. I just did not think about completing the square for like 40 straight minutes. It was pretty abysmal. But that's not gonna happen here. Alright, draw and describe the solid in the first octant bounded by the following surfaces. X squared plus y squared plus z is... Oh, I did not write the z. Is less than or equal to 9. Okay, first octant. Alright. This is... z is less than or equal to 9 minus x squared minus y squared, which is a paraboloid, everybody's favorite. And then y is less than or equal to 3x. So... y is less than or equal to 3x, which is going to be a plane. I keep hitting Command Z instead of Command S. Alright, so that 9 is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's just a chill circle, right? So 1, 1. Oh my god, this is so... Sorry. Not to shit on anybody's paraboloid, but like, oh my god, why are you making a paraboloid that looks like that, bro? What the hell? Okay, sure. And then y is less than or equal to 3x, so we go 1, 2, 3. Here. And here. That's not really gonna cut much of this parabola, though, is the thing. Wait, so when x equals 0... and z equals 0, y equals 3. Oh shit, because it's 3, not 9. Silly me. I was like, why are we doing a thing? First off, why does it look so shit? And then I was like, why are we cutting that? Why are we cutting that line if that line's not going through the shape? Because the line is going through the shape, everybody. Damie VTutor, the best cat boy math you can find. Meow nya. Meow nya. Okay. Something like this thing. And there's like, you know, this is chopped away. Like a it is probably gonna look something like this. Like there's a if you remember from drafting, when you cut a shape, it creates the profile of itself. So I'm somewhat of a drafting expert myself. I definitely didn't get a 19 out of 30 on my last homework. Okay, then determine the limits only. Okay, is this a complex shape is the first question we have to ask, and the answer is obviously yes, and obviously it's in the direction Wait. Is it? Wait a second. Okay, let's examine. Let's examine, chat. Is it complex in 2 directions, actually? Because, okay, so if we... Okay, the way that I like to do complexity... Wow, words are hard. Is I like to draw the different, like, profile views of the shape. It kind of just helps me out. So if we have the top, right, it's going to look like this. That's our XY. If we have the side, X is Z, so that's looking at it this way. We're gonna have... I think it's gonna look something like... this. Right, if we were looking on that head-on, this is a cut plane. And then if we look at it from from Z, Y, don't know why I wrote it like that. It's gonna look like this. I don't see how there's no complexity. But it could just be complex in 2 directions. Which means that we, I think, might need 3 triple integrals. But let me, before deciding that this thing is a new thing that I've never seen before, let's go on GeoGebra and pull it up. Okay, so this is gonna be x squared plus y squared plus z is less than or equal to 9. Okay, it didn't like that. It's not letting me it's not letting me see that. Oh wait, yes it is, I lied. It's just r. Nope, not letting me see that. Okay, cool. Thanks, GeoGebra. Maybe it won't let me do the less than? Yes, okay, it won't let me do the less than. And then we have y is less than... Oh, less than or... Whoa. Wait, y is less than or equal to 3x. Oh, never mind. We're chilling. Y equals... They just sort of set it strangely. Okay, which one is my x and y? Forget. This one, okay. Okay, chat, Okay, that's a little embarrassing. Do I take classes on campus every day? I do. I also live on campus, so... There are some people who are lucky enough. No one I know. No one in engineering. But some people don't have classes every day. Some people only have classes 4 days a week. I live in a dorm. I do live in a dorm. Next year, I will also be living on campus, but part of that is because I am not... I don't legally live in this state, like in California, because I live in the East Coast. So... The dorm at my university is expensive as hell. They actually require engineering students here. Well, they require all first years to live on campus at my university, and then they also require all engineering students to live on campus for 2 years. And I will say, like, I can understand... It's a lot easier to get to classes and, like, actually focus on work. Like, you know, as a first year, it's like... I think we do this with Polar, right? What do you guys think? But, yeah, it's a lot easier to, like, do work. Because I'm pretty, like... Managed to find a cheap basement to rent near Wynyard. Wow. Yeah, it can be... it can be pretty hard to find places. But no heat in the... You don't have heat in the winter, bro! Oh, I'm so sorry. You have, like, at least a space heater? Like this. We need to find this angle. Oh god, that's gonna be really annoying, actually. I guess we can just do trig stuff. How do I want to do this? Oh no, he wants it in dy dx, so that's alright. I guess we'll do it in that then. What is in my pocket? Oh, trash. Awesome. Okay, dy first? Ugh, it's like complex. Well, I guess I could do it in, oh, wait. Well, triple integration where, oh, he scribbled out cylindrical. That's so funny, yeah, because you can do it with cylindrical. And it would be probably smarter to do it with cylindrical, but I'm gonna assume this way is complex. So if we look at this, from the top we have sort of, is it in the first? Yep, first octant, so it's just here actually. I'll stay poor file until I can get my degree for job. Yeah, that's how a lot of people have to rough it. Capitalism sucks, man. The essay I have to write is on capitalism, sort of. Okay, so if we look at this side profile, then we see that it's sort of like this, and that's in the YZ direction. And then if we look at this other side profile, there's right, that goes there. Then we see that I think it's also complex in this direction. I'll have to see. Wait, let me make this a little bit more clear. That would look like sort of like this. And that's in the XZ. So it's complex in Y. He wants us to do DY first. Which is fine. We need to set up a lot of things, but before I do that, I just want to make sure that it is actually complex in two directions. If I look at it this way... Front on, come on, give me the front on. Yep, it's complex that way. And then is it... Because it's not a... that way, right? And then it's definitely... Oh, wait. Yeah, it's definitely also complex this way. Okay, he picked the more complex direction. Wait, did he? No, he picked the harder complex. I don't know why bro did that. That's fine. It's fine, it's fine. So yeah, in this case, this is that flat edge. Oh wait, that's not even what XZ looks like. No, it is. It's just weird. That's such a weird... This is the back. This is like the front and this is the back face. Okay, whatever. Anyway. Alright, we need this curve. That's the first thing. We need this curve A. So let's get curve A. Still got it. I still got it. Okay. So we have y equals 3x, right? Y equals 3x. We'll plug this in here. So that's x squared plus... Yes, this is a good thing. X squared plus 9x squared plus z is equal to 9. So that means that 10x squared plus z equals 9. Cool. Okay, now that curve is going to be useful for when we do dx. But we need to figure out what we're doing for y first. Okay, if you put somewhere in here and you pull forward, you can either hit this plane or you can either hit this sphere, this curve, which is the same for... Oh wait, maybe not. Maybe it isn't complex. Oh, maybe it's not complex if it's behind it. I'll think about it later. Anyway. Because you have to be able to pull forward. No, because sometimes you would hit that instead. Sometimes you'd hit the roof. You were up high. Anyway. Whatever. Wait, is that... Am I doing that in the right direction? I'm not doing that in the right direction. Whoopsies! Okay, so if we're down here, where are we gonna hit this curve first? This thing first. If we go, like, in here, I think, we would hit this first. But if we went, like, back farther, we'd hit that first. Think? Yeah. Okay, so for y, for the first integral, we can put the integrals over here. So this is for 1. Y hits plane. It'll be top y will be plane. So you go out, you hit the plane. So y equals 3x. And then... Wait, shit, no. Wait, I need this part, right? Wait a second. So if y is less than x... Yeah, it's this part. Oh, god damn it. Okay, where are you hitting? In here versus, like, way up here. Okay, that makes more sense. Yeah, I don't know why he would give us the other shittier side of it. I was like, bro, why are you doing that? The XY was right. Sorry, chat. Sorry, chat, about that. Okay, I just switched my color. There we go. Okay, so that means that it's gonna be like... For this is the YZ. Yeah. And then for XY, or for XZ, it'll look like this. Okay, so it must be that, like, if you have a hidden line on the front side of it. Anyway. Because there's a hidden line, here. I have a drafting final this Friday. I gotta practice. Okay. Okay. We can still do if it hits the plane or not. So if it's on the outside, will it hit the plane first or the inside? Oh, let's think, chat. If it's on the inside this portion, then it'll hit the plane first. So bot y equals 0, right? We're always gonna have that 0. So 0 to 3x, dy, dx, dz. And then for top x, we're gonna be hitting are we hitting the curve? Okay. In this case, which side of the picture are we on? If we have to hit that curve first, or if we want to hit the plane first, if we're really close to the plane. Wait, no. How do we hit the plane first? Oh no, we hit the bottom of the plane. Wait a second. Wait, I'm thinking. It's like in here. Projected like right there. If we're here, we'll hit that. Is it actually complex in this direction? Am I just like... I don't think it's complex in this direction. Doesn't it seem like it should be, though? Because it is, but like for some reason I'm not visualizing it. So when can you hit that line before you hit the other one? Is my picture just like Garbo? Like, you're never hitting that plane if you're pulling forward. You're always hitting the roof. I don't like this. I don't like it. It's rubbing me the wrong way. I feel like it should be a complex one. Maybe it's just not complex. But I feel like it should because he's saying only determine the limits. Let me take another look at this. Let's see the little computer generated sketch that's definitely right. Okay, so this is y, this is x. All right. Like if you look at it this way, where I don't understand. Because it's parallel with z. That plane. Doesn't that mean that it doesn't create? No, it would though. I'm so confused, chat. Okay, I might skip this one and come back to it. Yeah, we're skipping and come back to it. I don't know why. This one's just weirding me out. It might just be like not a double integral. Like a double triple integral. Okay. We'll do this other one. The other ones are pretty easy for parameterization, so. I haven't done any of that on stream. It's been a while since I talked to you guys about math, huh? Just because I've had like a lot of other shit going on. Okay. Draw and describe a solid bounded by the surface x squared plus y squared equals 5, so it's parallel to z-axis. And below the surface, z squared equals x squared over 3 plus y squared over 3. This is an oval, I think? Wait, no. It's... Let's see. So x squared plus y squared equals 5 is a circle, or a cylinder. So let's do that one first. Oops. We just have a root 5 here. Root 5. It is not... Oh, z is greater than 0. Okay, so it's not in the first octant. So we do have all this. So here's our cylinder. And then z squared equals x squared plus y squared. That is a cone, I'm pretty sure. Yeah, so z equals a square root of x squared over 3 plus y squared over 3. Now if it's 1 over 3, what does that do to the cone? Let's see. Make it bigger or smaller. So that means that for every z value, the x and y are smaller. I mean, z is bigger, so it's going to be a skinnier cone. So it's going to be a little strange, because it's going to be like a cone in here, right? But like, it's sort of cut out of this shape. It's also not... Oh. Is it? It definitely doesn't intersect. Oh, it'll just intersect it, whatever. Actually, I lied. Of course it will intersect. Because it keeps getting bigger, obviously. This goes up forever. Cool, so yeah, it looks something like that. So it looks something like if we were to cut a piece out of it. Something like that. And we cut a piece out of it. Yeah, just something like that. Cool. All right. Limit time. Determine the limits for the volume in the spherical and in the cylindrical integrations in the order of d rho, d phi, d theta, and dz, dr, d theta, respectively. Let's do spherical first. All right. So what is the maximum value of rho here? Oh, hey, bird. How's it going? Cone. Real. We need to find the intersection of these two. So if we have x squared plus y squared equals 5, we can just say z squared equals 1/3 times 5. So z equals the square root of 5/3. That is our intersection point. So our largest, the square root of 5/3 bigger than the square root of 5? No, it is not. So the largest z can, the largest that phi can get is square root of 5. Add to 0. So the way we do this is we say phi squared sine, sorry, rho squared sine phi d rho d phi d theta. Now we're going to talk about what phi can go to. So we want to find what this angle is. So if z is equal to 1, then what do the other ones equal? That is a great question. So if z equals 1, and we'll say z equals 1, x equals 1, because then we can just figure out this angle. Y equals 1 plus 1 over 3. Oh no. 1 minus 1 over 3. Equals 2/3. So then we have a triangle that's like this. Wait. Oh no, I need this value. Wait, that's y. No, that's x. 2/3. No, 1/3. 1. 2/3. Okay, so that means we need to find the sine of this angle. Which is what? Or I mean, I guess we could do whatever. So opposite over, so it'll be 3/2 equals sine. What is 3? Guys, what answer gives you 3/2? I feel like none of them. Is that point even on the cone? I mean, I guess it has to be. What is that? Oh, maybe I just need to like pick something. Maybe I need to pick like a known, no, because it won't be a known value. Sine of minus, anti-sine of anti-sine. Sorry, no. The answer is actually sine inverse of 3/2 minus 90 minus that. That's what it goes to. That's so lame. It's not gonna be that. There's definitely a different way to do this. I do not remember it. Let's see if I can remember it. What about when z equals root 5 over 3? What about that, huh? Maybe? That means that 5/3 equals x squared. Well, and we know that y is gonna be, well, it's gonna be 0. Wait, that's not, it's not useful. Oh wait, maybe it is useful. Wait, it kind of is. Let's see, wait a second. Maybe I'm cooking something. That means that this is root 5. This is root 5 over 3. If we want this angle, we do what? Opposite, so sine. So root 5 over 3 divided by root 5 equals square root of 1/3? What is that? What is that? That seems wrong. Let me look at this. Let me look at this cone. I swear to God, if this cone is like easy as hell and I'm just Maybe it might just be me. 1 divided by 3 times x squared plus y squared. Whoa! I'm guessing it's like 60 degrees. I'm gonna guess that, chat. Can I just find it? Can I just find that angle, please? I don't know how I would find it. I can change the color of it. No, not what I want. Okay, a little stumped. I mean, it shouldn't really be that hard, because, like, what if I just said z equals 0? Just need an angle of a cone. Why is this so tricky? What if I said if z equals 0 and, like, x equals 1? What about that? So 0 equals 1/3 plus y squared over 3. It's not 45 degrees, is the thing. Wait, I could find y. Oh, wait, I lied. That wouldn't be that. Wait, z equals 0. X equals 1. Wait. The brain is... Okay, I'm just gonna look up how to find an angle of a cone. I'm giving up. How to find angle of cone. I spelled every word in that sentence wrong. Of cone. Yes. Not that useful. Ugh. I need the height and the length. Wait. Gamers, I'm going through it. I just need 2 sides at an angle. I had to find an angle. What? Why is this so hard? Okay. This is root 5. We know that. And we know that z is root 5 over 3. So then what is this angle? This angle is opposite divided by... That's worse. Isn't that square root of... Shouldn't I be getting the same thing if I do... Oh no, it's a different angle. I don't need that angle, I want the other angle. Oh no. Okay, let me redraw this. Well, no, don't redraw that. I want this. Having a normal one. Okay. Opposite over adjacent, then. So 5 root 3, this is 1 over 3. Square root of 1 over 3 equals tan theta. When does that exist? This is the same thing as square, this is root 3, this is... Wait. This is the same thing as, this is the same thing as root 3 over 3. Which I think is 60? Wait. When it's 60, you have, 60 is the bigger one, so that means that sine is root 3 over 2 divided by 1/2. Equals root 3. Fuck, how is that? Ugh. Okay, if I could get the angle, this wouldn't be that bad. You put the angle here, oh, let me do it, let me see if I can do it in cylindrical. Isn't that easier? Wait, maybe I just convert stuff to it. Because x squared plus... I did x squared in... I might be able to solve for... it. Wait, so z sine... Wait a second. Giant brain move. That would be z... So z equals 5/3. Yeah, z equals 5/3, so then that means rho sine theta. Wait, rho sine theta or cos theta? Oh. I think it's cos theta. Okay, that one I need to check. I mean, just wildly looking around. Z in spherical chords. Okay, it's cos, yeah. So cos theta equals this, and at that point, this equals... when z equals 5/3, what is that? That's just like at the intersection, so that's at this point up here. Which means that... No, z squared. Oh god. No, it'd be easier to say square root of this. Isn't that... No, cosine this equals... like, square root of 1/3. I don't know, man. Yeah, that should be right. So what is cosine inverse of that? That's like nothing. That's like not a number. Fuck it, we ball. I'm gonna do one more. I know I was like, I'm gonna do all these, but like, I just do actually have to write an essay later. We'll do one more. I'll do them later. I'll do them maybe tomorrow? Maybe tomorrow. I'm probably not on stream, but maybe tomorrow. Draw the solid determined by two things. Let's just do a parameterization. It's faster. It's gonna look less fast. Squared z plus, but I swear it's faster. Plus 2x plus x plus x squared plus 2z plus 1. Okay. Where c is parameterized as... I lied. I want to do this in R. Do I want to do that in R? Yeah. Wait, no, I don't want to do that. That isn't R. That is over C. Oh, no, this is even easier than that. Okay, x equals sine to the 4th? Is that a 4? Bro is going mad with power. Y equals tan t squared, and then z equals cos t squared plus t plus 1. Okay, sure. Why not? Okay, we basically just plug all this stuff in. So, this will be tan squared t squared times cosine of, that is t plus... Nope, I can't factor it. God, okay. Times dx, which is 4 sine cubed t dt. But I'll put the dt at the end. Just imagine that it's there every time. Plus 2 sine to the 4th t and squared t squared cos t squared plus t plus 1 times dy, which is tans is secant squared. Okay, never mind. This is actually awful. Great. Okay, we'll just keep going. We'll just keep going. Sine to the fourth t. No, not this cos. Wait, is it cos? Please tell me it's cos. That was tan. Okay, that's fine. Tan squared. T squared. Plus 2. What was it? Cosine? I'm forgetting. Cosine. This has gotta cancel. This has gotta cancel out somehow. dz is sine. Two t plus 1. Oh my god. Gamers! Gamers, what is this? You guys can't even see the whole thing. Look at that. Look at that. Who decided that this was a good idea? Okay. Okay, let's look with our eyes real quick. This is all times. That means that we can pull out the same stuff from here. This one is plus, so we can pull out some stuff from the first one. Okay, let's see what we can do. Let's do this first. And then our 0 to 1. Thank God. Thank God it's not anything more than 0 to 1, because I would be really mad. Okay, we have our tan squared, t squared, and our cosine t squared plus t plus 1. And our sine, we do have a sine to the third t. And then the leftovers are 4 sine, nope, just 4. 4 plus 2 sine t times secant squared t squared 2t. How the hell are you supposed to do anything with this? Jesus Christ. Secant squared, that won't even cancel. I mean, you can make one tangent out of that, but like, jeez, man. Jeez. Little stumped at because then you can get the sine to the fourth out. Okay, there has to be some sort of trick to this though. Like some sort, wait, tan squared is sines. No, but you can't because the stuff inside is different. What the hell is my guy thinking? The way you do this is like when you just have it as dx, dy, dz, you just replace all the stuff. You can't like do the dx, dy, dz first. Unless it's not sine to the fourth and it's just like sine or something. It really looks like sine to the fourth though. Okay, maybe we just say what the hell ever. We just say we're done now. That seems like it's a pretty good idea to me. Yeah. I'm okay with being defeated by this one. This one is kind of bonkers in a way. I'll go like eat some dinner and like take a crack at this later. Or not. Well, so like I'm only stuck on little bits of them. Like I couldn't get the angle for one. I am a little confused about this one kind of makes me this paraboloid makes me a little bit nervous. I don't know why. I just feel like you can't, that's not a triple integral. Like, but it is. I feel like it should be, but like where are you hitting the... Oh shit, wait. No, it's okay. I think the thing, gamers, I think the thing is, if it was dx first, it would be two things. because you would either hit, wait. If you're doing dy first. No. No, this is the complex direction. You're either hitting... Oh, I see. I don't know why I was thinking about X. Because X, you're not hitting that. It's... Okay. I figured it out, guys. I got it. Because, like, if you pull forward in Y further back into it, then that's when you're hitting the plane. And when you pull into Y way out towards the front, that's when you're hitting into the... Okay. So this is... I just was confused. Here, wait. We could actually make some progress on this one. So if you're hitting the plane first, you're going to be in further. So your top X is going to be the curve, which is 10 x squared plus z equals 9. So that's... What is that? 9 minus z... x equals 9 minus z over 10 square root. And is it a positive? It is a positive. And then bottom x is 0. And then z top equals what? What do you hit? You're hitting... I mean, nothing, really. You're just... When y... z's 9. And then z bottom. 0. Okay, gamers. We're winning. We're winning big time. 0. And then it's really easy from there on out. Okay, cool. 0 to 9 plus... Okay, I'm glad we've actually ended up doing that one. Z is still gonna be from 0 to 9. We don't need to deal with that. And then X is gonna be from... This is the bottom one now. And it's gonna go out until it hits the circle, the paraboloid, which is if what? Y equals 0, so just 9 minus z. Yeah, square root of 9 minus z. And then for y, we're gonna go from it'd be 0 to the... We're hitting the paraboloid, not the plane. So that would be 9 minus z minus x squared square root. Awesome. Okay. Ended on a little bit of a win. Alright, guys. Thank you for hanging out. Sorry it was a little hectic. Also, sorry that I kept messing up the problems. That's silly funny. But yeah, I haven't really sat down and done math in a bit. Because, other work. I'm gonna go write this English paper. I hope you guys have a good day. Hopefully a better day than the night that I'm about to have writing this. Because it is a lot. But yeah, it was super fun hanging out with you guys. Bye, I'll see you all, I don't know. Probably this weekend, or maybe this weekend. Yeah, I don't know. My stream schedule is all over the place, dude. It's wild. All right, yeah, I'm gonna head out now. Bye.